Resistant starch is starch and starch degradation products that escape from digestion in the small intestine of healthy individuals. Resistant starch occurs naturally in foods but is also added to foods by the addition of isolated or manufactured types of resistant starch. Some types of resistant starch are fermented by the large intestinal microbiota, conferring benefits to human health through the production of short-chain fatty acids, increased bacterial mass, and promotion of butyrate-producing bacteria. Resistant starch functions as a mild laxative and consuming it can lead to flatulence at high doses. Origin and history. The concept of resistant starch arose from research in the 1970s and is currently considered to be one of three starch types: rapidly digested starch, slowly digested starch and resistant starch, each of which may affect levels of blood glucose. The Commission of the European Communities has supported research eventually leading to a definition of resistant starch. Health effects. Internal fermentation of resistant starch can cause gas when high quantities are consumed. One review estimated that the acceptable daily intake of resistant starch may be as high as 45 grams in adults, an amount exceeding the total recommended intake for dietary fiber of 25 to 38 grams per day. Resistant starch may contribute to colon health by increasing regularity, reducing pH, and producing short-chain fatty acids, among which butyrate is a primary energy source for colonic cells. In its various forms, resistant starch is digested and/or fermented variably, leading to preliminary research of resistant starch subtypes on disease risk. For example, although effects on weight management have been implicated, there is no evidence that resistant starch is an effect on human weight or energy balance, and it is not known if resistant starch has any part to play in helping treat obesity-related disease. When isolated resistant starch is used to substitute for flour in foods, the glycemic response of that food is reduced. There is preliminary evidence that resistant starch, used as a substitute for refined carbohydrate, may increase insulin sensitivity and may reduce the risk of type 2 diabetes. RS2-resistant starch from high amylose corn helps to treat diarrhea when delivered in oral rehydration solutions to people with cholera, rotavirus and other diarrheal diseases. Starch structure. Plants produce starch with different types of structure and shape characteristics which may affect digestion. For instance, smaller starch granules are more available to enzyme digestion because the larger percentage of surface area increases the enzyme binding rate. Starch consists of amylose and amylopectin which affect the textural properties of manufactured foods. Starches with high amylose content generally have increased resistant starch. Definition and categorization. Resistant starch is any starch or starch digestion products that are not digested and absorbed in the stomach or small intestine and pass on to the large intestine. RS has been categorized into four types. RS1 physically inaccessible or undigestible resistant starch, such as that found in seeds or legumes and unprocessed whole grains. RS2 resistant starch is inaccessible to enzymes due to starch conformation, as in high amylose corn starch. RS3 resistant starch that is formed when starch-containing foods are cooked and cooled, such as pasta. Occurs due to retrogradation, which refers to the collective processes of dissolved starch becoming less soluble after being heated and dissolved in water and then cooled. RS4 starches that have been chemically modified to resist digestion. Processing effects. Processing may affect the natural resistant starch content of foods. In general, processes that break down structural barriers to digestion reduce resistant starch content, with greater reductions resulting from processing. Whole grain wheat may contain as high as 14% resistant starch, while milled wheat flour may contain only 2%. Resistant starch content of cooked rice may decrease due to grinding or cooking. Other types of processing increase resistant starch content. If cooking includes excess water, the starch is gelatinized and becomes more digestible. However, if these starch gels are then cooled, they can form starch crystals resistant to digestive enzymes, such as those occurring in cooked and cooled cereals or potatoes. Cooling a boiled potato overnight increases the amount of resistant starch. Nutritional information. Resistant starch is considered both a dietary fiber and a functional fiber, depending on whether it is naturally in foods or added. Although the U.S. Institute of Medicine has defined total fiber as equal to functional fiber plus dietary fiber, U.S. food labeling does not distinguish between them. The Institute of Medicine panel on the definition of dietary fiber proposed two definitions: functional fiber is isolated, non-digestible carbohydrates that have beneficial physiological effects in humans, and dietary fiber as non-digestible carbohydrates and lignin that are intrinsic and intact in plants. They also propose that the prior classifications of soluble versus insoluble be phased out and replaced with viscous versus fermentable for each specific fiber. Uses resistant starch in food starch has been consumed by people and animals for thousands of years. Thus, foods containing resistant starch are already commonly consumed. It has been estimated that average resistant starch intake in developed countries ranges from 3 to 6 grams day for Northern Europeans, Australians and Americans, 8.5 grams day for Italians and 10 to 15 grams day in Indian and Chinese diets. The higher consumption of starch-containing foods like pasta and rice likely accounts for higher intake of resistant starch in Italy, India and China. Several studies have found that the traditional African diet is high in resistant starch. Rural black South Africans consume an average of 38 grams of resistant starch per day by having cooked and cooled corn porridge and beans in their diets. Isolated resistant starch isolated and extracted resistant starch and foods rich in resistant starch have been used to fortify foods to increase their dietary fiber content. Typically, food fortification utilizes RS2 resistant starch from high amylose corn, RS3 resistant starch from cassava and RS4 resistant starch from wheat and potato, as these sources can survive varying degrees of food processing without losing their resistant starch content. Resistant starch is a small particle size, white appearance, bland flavor and low water holding capacity. Resistant starch typically replaces flour in foods such as bread and other baked goods, pasta, cereal and batters because it can produce foods with similar color and texture of the original food. It has also been used for its textural properties in imitation cheese. Some types of resistant starch are used as dietary supplements in the United States. RS2 from potato starch and green banana starch maintain their resistance as long as they are consumed raw and unheated. If they are heated or baked, these types of starch become rapidly digestible. RS2 resistant starch from high amylose corn can be consumed raw or baked into foods. Physiological effects: by definition, resistant starch does not release glucose within the small intestine, but rather reaches the large intestine, where it is consumed or fermented by colonic bacteria. On a daily basis, human intestinal microbiota encounters more carbohydrates than any other dietary component. This includes resistant starch, non-starch polysaccharide fibers, oligosaccharides and simple sugars which have significance to colon health. The fermentation of resistant starch produces short-chain fatty acids, including acetate, propionate and butyrate, and increased bacterial cell mass. The short-chain fatty acids are produced in the large intestine where they are rapidly absorbed from the colon, then are metabolized in colonic epithelial cells, liver or other tissues. The fermentation of resistant starch produces more butyrate than other types of dietary fibers. Modest amounts of gases such as carbon dioxide, methane, and hydrogen are also produced in intestinal fermentation, with one review estimating that daily intake of resistant starch can be as high as 45 grams day in adults before gas production becomes problematic. References